You are standing on a lake. The water is calm. You are drilling for oil. This is routine work. You have done it hundreds of times. And then the drill bit hits something it should not. The lake beneath you begins to drain. A whirlpool forms. It grows. It pulls your drilling rig toward the center. You try to escape. The rig tilts. It slides into the vortex, and then it is gone. Along with the barges nearby, along with an entire island, along with 1 billion gallons of water. In less than 3 hours, a lake disappears into a hole in the ground, and you barely survive. November 14th, 1980. Lake Peigneur, Louisiana. A small freshwater lake, about 10 feet deep on average. Home to fishing camps, recreational boating, wildlife. Beneath the lake is a salt mine. The Diamond Crystal Salt Company has been mining there since 1919. Tunnels stretch for miles under the lake bed, 300 feet below the surface. The mining company and the oil companies operating on the lake have an agreement. Do not drill above the mine. Stay clear of the tunnels. Everyone knows the boundaries. But on this day, something goes wrong. A drilling rig operated by Texaco and the Wilson Brothers Oil Company is boring a hole in the lake bed. They believe they are in a safe location. They are not. The 14-inch drill bit punches through the roof of a salt mine tunnel. Water begins pouring into the mine. Miners below feel water dripping, then flowing, then flooding. They evacuate. All 55 escape. And above, on the lake, the whirlpool begins. This is the story of the Lake Peigneur disaster. The lake that drained into a salt mine. The barges and drilling rig that vanished. The ecosystem that died in hours. And the question that has never been fully answered: who miscalculated?
Lake Peigneur sits in Iberia Parish, Louisiana, just a few miles from the Gulf of Mexico. It is a shallow freshwater lake, roughly 1,300 acres, fed by rain and runoff. The water is brackish in some areas, but mostly fresh. The lake supports fish, birds, vegetation. Local residents fish there. Camps and small docks line the shore. It is a quiet place, unremarkable, until 1980. Beneath Lake Peigneur lies something valuable: salt. Massive deposits of rock salt formed millions of years ago when the area was covered by ancient seas. The salt beds are hundreds of feet thick. In the early 20th century, geologists identified the deposit. The Diamond Crystal Salt Company began mining operations in 1919. They sank a shaft on the edge of the lake, built processing facilities, and started extracting salt. The mining method was room and pillar. Miners excavate large chambers underground. They leave pillars of salt to support the roof. Over decades, the mine grew. Tunnels extended in multiple directions. By 1980, the mine had 50 miles of tunnels. Some passed directly beneath Lake Peigneur. The tunnels were about 300 feet below the lake bed. The roof thickness varied, but it was considered safe. The salt was stable. The mine had operated for over 60 years without incident. The lake above was also active. Oil and gas exploration had been ongoing in the region since the 1940s. Small drilling rigs operated on the lake. Barges supported the equipment. Drill holes were bored into the lake bed, searching for petroleum deposits. The oil companies and the salt mining company coordinated. Maps showed the mine boundaries. Drilling was restricted in certain areas. No one wanted to drill into the mine. It would be dangerous, catastrophic. Everyone knew that. By November 1980, Texaco and the Wilson Brothers Drilling Company had a contract to explore for oil on Lake Peigneur. They were using a barge-mounted drilling rig. The operation was routine. The crew had drilled multiple holes in the area. They followed maps. They stayed within approved zones. Or so they thought. On November 14th, the rig was positioned over a new drill site. The crew began boring. The drill went down, through sediment, through rock, deeper, 300 feet, 350, and then something changed. The drill bit encountered resistance. Then it broke through. Water began flowing down the hole, fast. The crew knew immediately something was wrong. Water should not be flowing down a drill hole. It should be flowing up, pushed by pressure from below. The crew tried to pull the drill bit back, but the flow intensified. The rig began to tilt. The barge was being pulled toward the hole. The crew abandoned the rig. They jumped into boats. They raced toward shore. Behind them, the drilling rig tilted further, and then it slid into the water and disappeared.
The Diamond Crystal Salt Mine beneath Lake Peigneur was an engineering achievement. Sinking a shaft and building a mine beneath a lake required careful planning. The mine entrance was on the shore. The shaft went straight down. At the bottom, tunnels radiated outward. The mining operation was extensive. Processing facilities on the surface refined the salt. Trucks hauled it to markets. The room and pillar method created a network of chambers and passageways. Each chamber could be 50 feet wide. Ceilings were 20 to 30 feet high. Pillars of salt were left standing to support the roof. The salt was stable, strong. It had supported the tunnels for decades. The mine employed about 40 workers. They operated in shifts, extracting salt, maintaining equipment, monitoring conditions. Safety was a priority. The company monitored for water intrusion. Small amounts of seepage were normal. Groundwater could find its way into any underground mine. But large-scale flooding was the nightmare scenario. If the lake above ever breached the mine, the results would be catastrophic. Millions of gallons of water pouring into the tunnels. No way to stop it. The mine would flood. Workers would have to evacuate. The operation would be destroyed. That is why coordination with oil drilling operations was critical. Maps showed the mine boundaries. Drilling companies were given clear instructions. Do not drill here. Stay outside these zones. For decades, the system worked. Drilling rigs operated on the lake. The mine operated below. No conflicts. No incidents. But maps can be wrong. Coordinates can be misread. And on November 14th, 1980, someone made a mistake.
November 14th, 1980. Morning. The drilling rig on Lake Peigneur is operating normally. The crew is experienced. The weather is clear. The drill bit is boring into the lake bed. Routine work. And then the drill bit hits something unexpected. The resistance changes. The drill breaks through into open space, and water begins flowing down the hole. The crew knows this is wrong. Water should not flow down. They try to reverse the drill, pull it back, but the flow is increasing. The barge is moving, being pulled toward the hole. The supervisor orders evacuation. The crew grabs life jackets. jumps into small boats, rows toward shore. Behind them, the drilling rig groans. The barge tilts, and then the entire rig slides into the water. It disappears into a growing whirlpool. Below, in the salt mine, workers are going about their tasks, and then someone notices water dripping from the ceiling. Not unusual. Mines have seepage. But then the drip becomes a stream. The stream becomes a torrent. Alarms sound, evacuation orders are given. 55 miners drop their tools. They run for the shaft. They climb into the elevator cages. The water is rising fast, pouring in. The mine is flooding. All 55 miners make it to the surface. They emerge from the shaft, safe. But below, the mine is filling with water. And above, on the lake, the whirlpool is growing. Fishermen on the lake see it, a swirling vortex. It starts small, then it expands 100 feet across, 200, 300. The water is being sucked down into the lake bed. Boats that were anchored nearby start drifting toward the whirlpool. Fishermen fire up their engines. They race for shore. Some barely make it. The pull is strong. The vortex is growing. 11 barges are moored on the lake. They are massive, hundreds of tons each. Some are loaded with equipment. Others are empty. The whirlpool reaches them. One by one, they are pulled in. They tilt, slide toward the center, and vanish, sucked down into the hole, disappearing beneath the surface. Gone.
An island in the lake, Jefferson Island, a small piece of land, trees, vegetation. It sits near the vortex. The water around it drains, the shoreline recedes, and then the island itself begins to collapse. The ground gives way, trees tilt and fall, soil slides into the water. The island is being consumed. Part of it disappears entirely. On shore, residents hear a roaring sound, like a waterfall. They run outside. They see the lake draining, water rushing toward a central point. The vortex is now a 1/4 mile wide. The lake level is dropping. Fast. Docks that were in the water are now on dry land. Boats are grounded. The lake is vanishing. And then, something even stranger happens. The Delcambre Canal connects Lake Peigneur to the Gulf of Mexico. Normally, water flows from the lake through the canal to the Gulf, but now the flow reverses. The canal is flowing backward. Gulf water is being pulled into the lake. Salt water rushes upstream. It pours into the lake to fill the void. The roar is deafening. Witnesses describe a waterfall. The canal, which is normally flat and slow, becomes a raging torrent. Water from the Gulf is pulled uphill against gravity, drawn by the massive suction of the draining lake. Barges in the canal are swept backward. They crash into each other, some capsize. The canal becomes a chaotic river flowing the wrong direction. Within 3 hours, the lake is transformed. Over 1 billion gallons of water have drained into the salt mine. The mine is completely flooded. The tunnels are filled. The lake, which was 10 feet deep, is now over 1,000 feet deep in some areas. A massive sinkhole has formed. The whirlpool slows, stops, and the lake begins to refill, but not with fresh water, with salt water from the Gulf. The environmental impact is immediate. Lake Peigneur was a freshwater ecosystem. Fish, plants, birds. The saltwater influx changes everything. Freshwater species cannot survive. They perish. The lake becomes brackish, then fully saline. The ecosystem is destroyed. Years later, the lake remains salt water. The damage is permanent. And the questions begin. How did this happen? Who was responsible? The drilling rig was operated by Texaco and Wilson Brothers.
They claimed they were drilling in an approved location. The maps showed they were clear of the mine. Diamond Crystal Salt Company claims the drillers were off course, that they drilled directly into a mine tunnel. The lawsuits begin. They last for years. Investigators study the maps, the coordinates, the drill location, and they find discrepancies. The maps used by the drillers may have been outdated, or the coordinates were misread, or both. The exact cause is never fully determined. Both sides settle lawsuits, no criminal charges are filed, but the mystery remains. Who made the mistake? The answer is lost in conflicting data and legal settlements.
There was no completion for Lake Peigneur as it was. The lake was destroyed, transformed. A freshwater ecosystem became a saltwater lake in hours. The salt mine was gone, flooded beyond recovery. The drilling operation was ended. The rig was lost. But miraculously, no one perished. All 55 miners escaped. All drilling crew members survived. The fishermen on the lake made it to shore. Residents near the lake evacuated safely. It is one of the most catastrophic infrastructure failures in American history with zero loss of life. The fact that everyone survived is extraordinary. The environmental and economic damage was severe. The salt mine represented decades of investment. Jobs were lost. The mining company filed for damages. The lake's ecosystem was destroyed. Property values around the lake collapsed. Docks and camps were damaged or destroyed. The island that partially vanished was private property. The owner sued. Legal battles consumed years. Texaco, Wilson Brothers, and Diamond Crystal Salt Company all blamed each other. Settlements were reached. Exact amounts were not disclosed. Insurance companies paid out millions, but no one admitted fault. The official cause was listed as a drilling location error. But whose error? That question was never definitively answered. Over time, Lake Peigneur stabilized. The sinkhole filled with salt water. The lake reached a new equilibrium. It is now much deeper than before, over 1,000 feet in the deepest areas. The saltwater remains. A new ecosystem has developed. Saltwater fish, different vegetation. It is a different lake. The old Lake Peigneur is gone forever. The site became a point of interest. Researchers studied the disaster. Engineers analyzed what went wrong. The event is taught in geology and engineering courses. A case study in what happens when drilling operations intersect with underground mines. The importance of accurate mapping, coordination, double-checking coordinates. A small memorial exists near the lake. It acknowledges the disaster, the loss of the lake as it was, and the miracle that no one perished. Visitors can see the lake today. It looks peaceful, but beneath the surface is a flooded mine, tunnels filled with water, equipment entombed, barges resting on the mine floor, a submerged industrial graveyard.
The Lake Peigneur disaster changed how drilling operations near underground mines are conducted. Before 1980, coordination was often informal. Maps were shared, drillers were told to stay clear of certain areas, but enforcement was lax. Double-checking was rare. The assumption was that experienced crews would not make mistakes. Lake Peigneur proved that assumption wrong. Even experienced operators can misread coordinates. Maps can be outdated, communication can fail. After the disaster, regulations were tightened. Drilling near known underground structures now requires extensive permitting. Multiple agencies review plans. Coordinates are verified independently. Real-time monitoring is mandatory. The disaster also highlighted the risk of underground salt mines. Salt is soluble. When fresh water contacts salt, it dissolves. The Lake Peigneur event created a massive dissolution cavity. The mine tunnels collapsed as salt water eroded the pillars. The cavity grew. The sinkhole expanded. It is a reminder that underground mines are not permanent. They are vulnerable.
Environmental groups cite Lake Peigneur as an example of industrial activity destroying ecosystems. A freshwater lake became saltwater in hours. Species were lost, habitat was eliminated. The recovery took decades, and even now the lake is not what it was. It is a cautionary tale about the fragility of natural systems. The economic impact on the region was significant. The salt mine employed dozens. It provided jobs, tax revenue. When it flooded, those were lost. The lake supported fishing, recreation, tourism. The disaster ended much of that. Property values dropped, businesses closed, the community struggled to recover. But there is also a story of resilience. The residents rebuilt. New businesses emerged. The lake, though changed, still attracts visitors. The disaster became part of local history, a story told to newcomers, a reminder of the day the lake drained. The fact that no one perished is still remarkable. The miners had minutes to evacuate. They all made it. The drilling crew abandoned the rig in time. The fishermen reached shore. Luck played a role, but so did training. The miners knew evacuation procedures. They practiced drills. When the alarm sounded, they acted. That training saved lives. Lake Peigneur also stands as a reminder that nature is unpredictable. A small drilling error created a cascade of events. A hole in a mine roof became a whirlpool. A whirlpool drained a lake. A lake became a saltwater sinkhole. The scale of the disaster was far beyond what anyone imagined. A 14-inch drill bit caused 1 billion gallons of water to disappear. The Lake Peigneur disaster of 1980 remains one of the strangest infrastructure failures in American history. A drilling rig punctured a salt mine. An entire lake drained into the tunnels in less than 3 hours. 11 barges were sucked down, a drilling rig vanished, an island collapsed, and a canal reversed direction, pulling Gulf saltwater backward to fill the void. Miraculously, all 55 miners escaped and no one lost their life, but a freshwater ecosystem died in hours, and the lake was transformed forever. The question of who miscalculated the drill site has never been fully answered. Legal settlements buried the details. Both the oil company and the mining company blamed each other. The truth is lost in conflicting maps and testimony, but the result is undeniable. A lake disappeared, an ecosystem was destroyed, and an industrial accident created one of the deepest lakes in Louisiana. If you want to uncover more stories of American infrastructure hiding dark secrets, subscribe to Hidden America. Next time, we will explore the St. Francis Dam collapse in California, where William Mulholland's dam failed catastrophically just 2 years after completion, unleashing a wall of water that traveled 54 miles to the Pacific Ocean and left over 400 people gone. We will investigate the ignored warnings, the unstable rock, and why Mulholland took full responsibility but faced no charges. Subscribe now for more hidden infrastructure stories. And remember, Lake Peigneur taught America that a small mistake can have catastrophic consequences. A 14-inch hole drained 1 billion gallons and changed a lake forever.